Well, I woke up this morning and realized there are only 7 weeks before I get on the airplane and leave this town and this workshop. So I've really got to get my stuff in gear and get this car moving on the road so it can be registered and inspected and tested and titled. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. Well, a little excitement at the shop. That big white truck right there tried to make a right-hand turn and completely snapped off the telephone pole. And he's so lucky he didn't hit that fire hydrant. AT&T to the rescue. I think he's just going to undo the wires because he says he's got a crew coming out for the pole later. Alright, the guys with the shovels are here, digging this thing out, getting ready to put the new one in. And the crew of guys was just here. We have a nice shiny new pole, and the lineman pushed it really up nice and high so it's not sagging anymore, which is really good. And that's an interesting way to leave your job, but it'll do. Okay. Got a free piece of caution tape. That means no more superfluous projects that aren't directly related to making the wheels turn. So that's batteries, cables, boxes, and wiring. Everything else falls to the wayside. Now, my first task is to actually finish off the front battery box, because when the guys made this modification, they didn't put the this long nut back in, which acts as the holding place for this rod, which then holds the cover on the top in 2 places. So I figured, let's weld it, because I don't want to pay their shop rates anymore, and I'm going to need to weld up the cooling system bracketry in the back of the car anyway, so I may as well learn. How hard can it be? Don't worry, I'm fluent in sarcasm. So, happily at my disposal, I have stick welder, MIG welder, and TIG welder. I reviewed a bunch of YouTube videos, and it seems like TIG is the best thing for me. It's clean, makes a really nice clean bead. The machine is a top-level machine with a crap ton of customization. I've watched some YouTube videos and I've got the right numbers to plug in there, and we'll give it a shot. Luckily, it's not really structural. It just has to hold on enough to make sure that the lid doesn't come flying off. One on this side, one on that side. That'll give me some practice, and when I start working on the other one. Now, of course, I'm going to do some practice on this first, just to fill up these 2 slots I cut in this piece of steel, and get some practice in, and then go to town on this thing. How hard can it be? I've got all the safety gear. I've got the filling rod. The tungsten tip is good. I've got gloves and a smock. I've got an auto darkening helmet. I've got a lot of argon in that bottle, and everything is ready to go. So cross your fingers that I still have all of my fingers when this is done. That's pretty awful. Huge and blobby. It's difficult to get a feel for how big of a blob I'm putting on there, but clearly I'm putting too much. So we'll do a few more practices. Okay, my second attempt. Ooh, that's still hot. I basically filled all this in, and I think that's pretty good for a first go. My first one is terrible, but I'm getting more blob control here. And as AVE says, a grinder and paint make me the welder I ain't. And that's going to be good enough to get this little nut on there. So let's commit to it. All right, look at that bolt, welded in beautifully. Boy, I'm really good at this. And that's a complete lie because I couldn't get the weld to stick in here. So I ended up taking it back to the machine shop that did the original work, and for $38 they welded these nuts on. They did say that they used a MIG welder in order to feed the thin metal rod into this gap. That could have been my problem. Also could have been that I had it plugged into the wrong plug. 120 versus 240 here in the shop, and it just wasn't getting hot enough. Anyway, time for a coat of paint, then we can start finalizing the front battery box. Welcome to the completion of the mock-up of the front battery box. This battery box will go into the frunk of that Porsche 914 right there, and its job is to hold these three Tesla Model S battery modules. The modules will go here, held down by these clamps, supported with padding and a sheet of mica insulation between the three, nice and securely held in place. In order to get this to function nicely in the car, we need three things to come in and out. We need power, we need cooling, and we need data. The first and most important thing is the power that makes the loop that forms the entire battery pack with the front three and the back three Tesla modules. These wires, the 2-aught cable, will come up from the back. It will come around here, go through these two cable clamps, and then in here. One will come through this massive DC circuit breaker and disconnect, and back around here. It will then go in series with the three modules using really cool Z bus bars from Amp Revolt, and that will complete the electrical power loop. In order to keep the modules happy in Spain, they need to be cooled. That will be performed with this cooling loop, cool water in here, warm water back out. The water tubes will come through the heater duct that's on the side of the car. It will come up here, through these two, and in here. These will daisy chain through the water fittings on the three modules, effectively keeping the modules nice and cool under the command of EVTV V2 box, as I've shown before. The third thing is data. These modules have a daisy-chained data bus that tells the Tesla car computers the state of the modules, their temperatures, their cell voltages, and other interesting things, and we need to preserve that. So the EVTV folks have reverse engineered the data flow, and they know how to talk to these modules, but we need to have a wire. So the wire will daisy chain back and forth between these modules. It will come up here, it will go through this cable clamp, and terminate in this connector. We have a detachable mated Molex connector that will then follow through this hole, and go down here through the firewall and to the back of the car. And I'd like to thank Professor Deacon at Southeast Missouri University, also known as SEMO, for his very generous help in printing all of these cable clamps on their 3D printer setup at the university lab. I designed them, and he printed them. And then I had to redesign them, and he printed them again. And one of the coolest things is the shroud here that covers up the fairly rough hole I had to drill to get this through connector in place. This thing is 2 millimeters thick, and it really nicely finishes off the look of that connector in the front of the box. So here the front battery box is wrapped in vinyl inside and out. It looks a lot better than it did. Not perfect, to my eye, but it'll do. Now let's go ahead and install all that hardware back into here. And here it is with all the hardware reinstalled. Next stop in there, once I get the frame mounted. That's tomorrow. I'm going home. Just before we wrap up, I want to thank my Patreons, Peter Bouvier and Puppy, for their support. We also just popped over 2,000 subscribers, which is quite a nice milestone for my little channel. All support is greatly appreciated. Hey, I hope you enjoyed the video, and if so, please give it a thumbs up. I see that 81% of the viewers aren't subscribed. Please do, as it does help the YouTube algorithm. Take care and see you next time.